Hi class, Mrs. Calvi here. Quick review on translating between tables and expressions. So I have a table here and I am looking at Riley's age and Ashley's age. And my directions are that I need to come up with an algebraic expression telling me how their ages relate to each other. So here, if you notice under Riley's age, this is going to be my variable, and they're telling us that the variable is n. The first thing I need to do is I need to find a relationship between Riley's age and Ashley's age. Well, I noticed that Riley's age she's younger than Ashley. So my number is going from a smaller number to a larger number. So if my number is going from a smaller number to a larger number, I'm going to either be adding or multiplying. So I'm going to always try adding first because that's easier. So I'm thinking to myself, well, 9 plus what is going to get me to 11? Well, I know that 9 plus 2 gives me 11. But I have to make sure that that works for all of these. So let me see if 10 plus 2, does that give me 12? Yes, it does. Let's see if 11 plus 2, does that give me 13? Yes, it does. 12 plus 2, does that give me 14? Yes, it does. So now I know the algebraic expression is going to be my n, my variable, or Riley's age, plus 2. So my algebraic expression is going to be n plus 2. Okay? And basically what that is saying is when Riley's age is n, Ashley's age is n plus 2. Okay? So let's try another example. Okay, so here my chart, we're talking about eggs and dozens of eggs. So I need to find the relationship between my eggs and between my dozens. So I am starting with a larger number going to a smaller number. So if I ever am going from a larger number to a smaller number, I'm going to either try subtraction or division, okay? And I'm going to start with subtraction first just because that's easier. So I have to think, well, 12 minus what is going to give me a 1? Well, 12 minus 11 gives me a 1, so that works out. Let's see, 24 minus 11. Does that give me a 2? Well, 24 minus 11 does not give me 2. So I know my operation is not going to be subtraction. So now I have to try, what am I going to try next? I'm going to try division next because I'm going from a larger number to a smaller number. So let's see, 12 divided by what is going to give me 1? Well, 12 divided by 12 gives me 1. Let's see if that works for the rest. 24 divided by 12. 24 divided by 12 just so happens gives me 2. 36 divided by 12. Does that give me 3? 36 divided by 12 does give me 3. And 48 divided by 12. Does that give me 4? 48 divided by 12 does give me 4. So now I know the amount of eggs, or E, my variable E, divided by 12 is going to be my algebraic expression. So in this box, I would put E divided by 12. Or you guys now know that we're not going to be using the division symbol all that often. We're going to be using the fraction bar. So E divided by 12 also. Okay? So remember, if you're going from a larger number to a smaller number, you're trying subtraction or division. If we were going from a smaller number to a larger number, such as in the previous example with the age, we would try addition and subtraction. All right? So let's try a more difficult problem in a different table. Okay, so this example is pretty important. First of all, if you notice, our table is now going horizontally from left to right. The previous tables were going vertically, which was up and down. So here, we're going to be looking at our top values. That's going to be our variable row. And we're looking to see if this number is smaller or larger than the number below it. So here, I'm going from a 1 to a 3. So I'm going from a smaller number to a larger number. So don't forget, if I'm going from a smaller to a larger, I'm going to try addition or multiplication first. Okay? Well, 1 plus what would get me to 3? Well, 1 plus 2 would get me to 3. So let's see if that works to the next number. Is 2 plus 2 equal to 5? Well, the answer is no. So I know that I cannot use addition. Addition is not working. Okay? So addition doesn't work. So now I'm going to try multiplication. Well, 1 times what gives me 3? Well, 1 times 3 gives me 3. Well, let's see. Is 2 times 3 equal to 5? 2 times 3 does not equal 5. So we tried addition. It did not work. And now we tried multiplication, and that did not work either. So if you try both operations and it does not work out, what that's telling you is that it's a two-step algebraic expression. So watch what I do. Once I try both operations, my next step is to do this. I'm going to see the change in my values in my numbers at the bottom. So I'm going from a 3 to a 5. How do I get from a 3 to a 5? I am adding 2. Well, how am I getting from 5 to 7? I am adding 2. How do I get from 7 to 9? I'm adding 2. And how do I get from 9 to 11? I'm adding 2. So now, listen carefully. This does not mean I'm taking my 1 and adding 2. Yes, it says plus 2 down here, but what that's going to tell me is I'm going to multiply my number on top by 2. I'm multiplying it by 2. Okay? Even though it says to add, we're multiplying it. So I'm going to take 1 times 2. Well, 1 times 2 does not give me 3 though. So how do I get from 2 to 3? Because 1 times 2 equals 2, but then how many more do I have to get to 3? Well, if I add 1, I then get to 3. So let's see if this now works. So multiplying my values on top by 2 and then adding 1 to get to my bottom number. So let's see, 2 times 2 is 4, plus 1 gives me 5. That works out. 3 times 2 gives me 6, plus 1 gives me 7. 4 times 2 is 8, plus 1 gives me 9. 5 times 2 gives me 10. 10 plus 1 gives me 11. So I actually figured out what my pattern was. Now what I have to figure out is I need to figure out what my algebraic expression is going to be. So watch carefully. So what happened to my n values? These are all of my n values. Well, I took each n value and I multiplied it by 2. Then what I did was I added 1 to get to my final answer. So that means I'm taking my n times 2 and then I added 1. But if you remember, I do not need a multiplication sign, right? Because when I have a variable next to a number, I know it means multiplication. So n2 plus 1. Uh-oh, what did we say about a variable before a number? We should not have a variable before the number. So we're just going to switch how this looks. And we are going to write this as 2n plus 1. And this is the algebraic expression that represents this table. So in this box here, I would be putting 2n plus 1. Okay? I understand it's a lot of steps, but the more you do it, the easier it becomes. First thing you're going to do is you're going to look to see, I'm going from a smaller number to a larger number. I'm going to either add or multiply. We tried addition, it did not work. We tried multiplication, it didn't work. If both don't work, you then find the change in your values down below. So here, these were all the same. So it was a plus 2 plus 2. Being that these were all adding 2, I knew that's what I was going to use to multiply my n values by. So then I did 1 times 2. That gave me 2. But for me to get from a 2 to a 3, I had to add 1. So I did then 2 times 2, added 1, got to 5. 3 times 2, added 1, got to 7, and so on and so forth. And then I looked to see how I was going to write my algebraic expression. Well, what did I do to my n values? Well, I multiplied them by 2. So that means 2n, which means 2 times n. And then what I did next was I added 1 to each one. Okay? I know it sounds like it's very difficult, but the more you do it, the easier it becomes. Okay? All right, class, that's it for now, and I will talk to you soon.